We're on problem 73. 73. How much did a certain telephone call cost? All right, well, we know nothing so far. Statement 1. The call lasted 53 minutes. 53 minutes. Well, unless they tell us how much it cost per minute, that still doesn't tell us how much the call costs. Statement 2 tells us the cost for the first 3 minutes was 5 times the cost for each additional minute. So first 3 minutes, 5 times additional minute. Well, that still doesn't help us. I mean, the cost for the first 3 minutes might have been 5 cents a minute, and then we might have been 1 cent a minute after that. Or it could have been 10 cents a minute, and then, or let me make a multiple of 3, 12 cents a minute, and then 4 cents after that. So it tells us nothing about the actual, both of these satisfy that statement. And actually, if I had to be honest, this statement is slightly ambiguous because they're saying the cost for the first 3 minutes. Do they mean that the total cost for the first 3 minutes was 5 times each additional minute? Or was it the cost per minute of the first 3 minutes was 5 times additional minutes? Well, either way, both statements combined don't help us because we're not able to figure out the cost per minute, and then we could apply it to this. So they are both useless. 74. 74. In a certain office, 50% of the employees are college graduates. So let's say 50% college, I'll call that C. 50%, or I could say 50% of the employees are college graduate, right? 60% of the employees are over 40 years old. So it says 60% of the employees equal, we'll call it O for over 40. Over 40. I don't know where this is going. I'm just making up numbers. And they said if 30% of those over 40 have master's degrees, how many of the employees over 40 have master degrees? Okay, so 30% of the over 40 have master's degrees. I don't know, I'm just trying to make up some notation. How many of the employees over 40 have master's degrees? So we're actually trying to come up with this number. So if we knew how many employees over 40 there were, we would be set because we just multiplied 30% times that. If we knew how many employees there were, we would be all set because we could figure out the number over 40 and then multiply 30 times that. So let's see what they give us. Statement 1. Exactly 100 of the employees are college graduate. 100 of. So essentially, C is equal to 100, right? 100 of the employees are college graduates. And they told us that 50% of the employees are college graduates. So that means how many total employees are there? That means that there are 200 employees. Right? 100 is 50% of 200. So that told us there are 200 employees. If there are 200 employees, how many employees over 40 are there? Well, that's O, right? O for over 40. Well, that's just 60% of 200. That's 120. And then how many over 40 with master's degrees? Let's call that OMD. Or that's band. Well, anyway. How many of these are there? Over 40 with master's degrees. Well, that's 30% of over 40. So that's 30%. This is an O. This is 30% of this, which is equal to, so over 40 with master's degrees is equal to 36. And we would be done. So statement 1 alone is sufficient. This is, I should call it over 40 instead of a 0. Don't want to get confused. Over 40 with master's degrees. So statement 2. Of the employees 40 years old or less, 25% have master's degrees. So that doesn't tell us anything, really. I mean, it doesn't tell us how many employees there are over 40, which was one of the things that we realized we had to figure out. It doesn't help us figure out how many total employees there are, so we really can't do this type of logic. So it seems fairly useless. So, yeah, employees 40 years old or less, 25% have master's. No, this is a useless piece of information. So the answer is, what is that? I always forget. A, statement alone is sufficient and statement 2 is useless. 75. 75. They ask, is RST equal to 1? Statement 1 tells us that RS is equal to 1. In statement 2, I mean, this by itself doesn't help us, right? If RS is equal to 1, the only way that this whole thing is going to be equal to 1 is if T is also equal to 1. But we don't know that. So, I mean, T could be equal to 10. So statement 1 alone doesn't help us. Statement 2 tells us ST is equal to 1. Well, I could show that even if we have both of these statements, that we still can't prove this. For example, I can come up with a scenario that meets both statements where this is true. Because I can say, what if R is equal to 1, S is equal to 1, and T is equal to 1? Then we can make both of these statements true. So then definitely R, S, T is equal to 1. But let me see if I can construct something where this doesn't hold up. So what if R is equal to 6, S is equal to 1/6, and then T is equal to 6? So then R times S would still be equal to 1, right? S times T would still be equal to 1, but what is RST now? It's 6 times 1/6 times 6, which is equal to 6. So I can satisfy both of these, but still end up not knowing whether it equals 1 or something different. And I just picked this arbitrary. You can actually kind of pick an arbitrary number here and set this up. So anyway, this is E. I think that's E, right? Both statements combined are useless. Right, they're not sufficient. Next problem. Next problem. Let me turn the page. It's problem 76. And they've drawn a nice pie chart for us, which I'll reproduce. 76. Total expenses for the 5 divisions of company H. Let me draw this pie chart. That's my okay, and then they have a bunch of, see how many pies are there? There are 5 pies. I'll try to draw it the way they do it. So that's 1, 2, 3. They have one more. There you go. So that looks pretty close to what they've drawn. And then they write, this is Q, R, S, T, and P. O is the center. They call this angle X. Fine, fair enough. And this is the total expenses for the 5 divisions. So each of these are divisions for company H. 76. The figure above represents a circle graph of the company H's total expenses broken down by the expenses for each of its 5 divisions. If O is the center of the circle, fair enough. So this is the center, although I didn't draw it quite the center. If O is the center of the circle, and if company H's total expenses are $5.4 million, what are the expenses for division R? So the whole thing is 5.4. So the whole pie is $5.4 million. And we need to figure out what R is equal to. So if we know what angle X is, so the whole expenses are 360 degrees. So whatever fraction X is of 360 degrees, that's going to be the fraction that R is of the total expenses. So let's see if they give us that, if we can figure out what angle X is. 1. X is equal to 94. Well, we're done. Because X over the total degrees in the circle, so 94 over 360 degrees, that's going to be equal to the expenses of division R divided by the total expenses, 5.4 million. And this is a trivial equation to solve, so 1 alone is sufficient. Let's see what they give us for statement number 2. The total expenses for divisions S and T are twice as much as the expenses for division R. So they're saying that this right here is twice as much as what we're trying to figure out, is this right here. Well, that doesn't help us much because, P and Q could be arbitrarily small or large. I mean, these two combined could be $2 and this could be $1, right? In which case P and Q are the bulk of the expenses for the company. Or maybe these two are $4 and R is $2, which are all possible. And these would represent the rest of the, whatever gets you to $5.4 million. So statement 2 is useless. So statement 1 alone is sufficient and statement 2 does us no good. And I am out of time. I'll see you in the next video.